that can attract magnetic substance. So we have come across with two types of magnets. Magnets are either temporary or permanent. We usually have temporary magnet as iron. Okay, iron, when you remove the magnet from it, is going to lose its magnetic property. Permanent magnet is going to be steel. Okay, what is magnetic field? Is a space around a magnet where the magnetic effect can be felt. Okay, so space around magnet where magnetic effect can be. Okay, how many poles of magnet are there?
Two poles, north and
Two
south.
poles.
Two poles, north and south. Okay. Okay. Your magnetic field is strongest at the poles and weakest at the center. Okay. Magnetic field is strongest. ठीक है भाई अच्छा अगर ये किसी का फैन है ये थोड़ा सा नॉइज कर रहा है तो म्यूट कर लो माइक जरूरत पड़ेगी तो फिर मैं बोलूंगा माइक ऑन कर देना देख लो क्योंकि क्लास रिकॉर्डिंग है फिर उसमें वो पीछे से आवाज आती रहेगी तो field is weakest at the center and it is strong. My fan was creating noise. I just switched it off. Okay, so field is strongest at the poles and is weakest at the center. Okay, can anyone tell me from where the magnetic field lines are going to originate and where they're going to go?
Sir, from north to south and south north.
Hmm. So the field lines are going to originate from the North Pole and they're going to go towards the South Pole. Okay, so if I supposed to draw the field lines, so it's like this. Okay, the North Pole is going to like the field lines are going to go out. Okay, and go like this, and from here like this, and towards the south. Okay, so this is how your magnetic field lines are going to. So they can give you a magnet, and they can ask you to draw the magnetic field lines. So the thing that is important is you have to draw like the number of field lines. Number one, the direction of arrow is the most important thing. They originate from your north pole and go towards the south. All right. You can take screenshots and then I'm going to go. Okay, so Ali Beta, you joined a bit late. So far, what we have discussed is the magnet is a substance that attracts magnetic materials. Magnet is going to be either permanent or temporary. The temporary magnet is going to be like iron, and temporary magnet and permanent magnet is going to be steel. If you put a magnet and there is space around the magnet, and you see that other substances are either attracted or repelled, so that area is called a magnetic field. Magnetic field is strongest at the poles and is weakest at the center. The magnetic field lines come from your what you can say. They come from the north and they enter towards the south. Okay. Any confusion so far? Okay, perfect.
No, sir.
Then there's a rule like the charges. Two same charges are going to be attracting each other. Is it true or false? Two
Sir,
same
same
charges
charges will repel.
repel. Okay. So to yeah.
Repel.
So if I put a north and north, okay. If I put a north and a north, so you're going to have repulsion. Okay. So what's going to happen? That you're going to have magnetic field lines which are originating from the north. Okay, like this. So there's no attraction. There's a null point in between. Okay, you guys are going to study a null point in your A levels. Null point is a point where the fields are being cancelled by each other. So this is a null point. Okay, so this is repulsion. Same goes for your south and south. So again, we'll experience repulsion. The field is going to originate towards the south. Okay, so there would be a repulsion again. Okay, but if you place a north and a south together, whole full strength accepts the I message him to join as well. North to south. So three lines are going to go all the way around like this. Okay, so this can be another question. So you can have the magnets being placed horizontally, or it could be vertical. So you'll be asked to draw the magnetic field lines. Is it clear? Okay, so now what we have covered so far is the definition of magnet. What is magnetic field? The ones who have joined a bit later, I'll share the notes with you so you can go through this. This was quite easy. The magnetic field lines, they originate from north to south, and if two same poles are being placed together, it's repulsion, and if opposite poles are placed together, so we feel attraction. Okay. Now the thing is that how can we make magnets? How can we make magnets? There are two types of magnets. There are permanent magnets. There are natural magnets, which are called lodestones, which like you get them from the mountains and like the ores and the what you can say, what do you call them? Where we can extract the minerals, a quarry or something like that. Mine. Jazakallah, mine. Yeah, so they're found from the mines, but we can make some magnets on our own as well. Okay, so now let's see how we can make the magnet. So we can make a magnet by putting, okay, for example, this is a magnet. Okay, and you have placed another object with a magnet. Okay, this is going to be your magnet. Okay, and this is what you call the induced magnet. Now, if you have some paper clips which are made up of iron or steel, so they will be attracted. Okay. So now my question is that if the induced magnet is made up of iron, what's going to happen if I remove the original magnet away?
Sir, it will be temporarily magnetized.
It's going to be temporarily magnetized. Very good. So the paper clips will fall down because the magnetism will be lost. Okay. But if it is steel, then what's going to happen?
Sir, permanent magnetism.
It's going to be a permanent
It
magnet.
won't fall
Very
down.
good. Exactly. Okay. So this is induction method in which we are basically placing together two magnets. Okay. And because of the one magnet, the other material gets magnetized as well. Okay. So this induced magnet, sometimes we also call that to be a ferromagnet, which is having the property of a magnet. Depending on the material which we have chosen, the magnetism is either strong or weak. Okay. There is another method in which we are going to have an iron bar or a steel bar, and we're going to place this within a solenoid having direct current. Okay, and this direct current is going to make this rod or the bar, so you're DC. Okay, please remember that we have to demagnetize, we'll be using alternating current, and when we have to magnetize, so we'll be using direct current. Okay, so what happens when direct current is flowing into the metal, So the arrangement of the particles within the metal will be in such a manner that the metal now becomes a magnet. Okay, the only thing which is like special or the characteristic of a magnet is the arrangement of the particles within a magnet. That is the only thing that makes a magnet attracts the object towards us. If any case we are going to disturb the arrangement, it is going to demagnetize. Okay, so these are the two methods you can remember for magnetizing. We'll do a past paper session as well. There is a very important four marker. Like it's asked in the latest papers. If someone remember, Joshka, I made you do that thing. Zainab, I remember I made you do that one as well. Even Habiba, I made you do that as well. So some of the students I made, but because we are doing it right now in the group class, so this is the first time for you guys. So you need to remember that if you want to check out whether a substance or a material is magnetized, okay, how can we check it? So we can check it by placing the other materials towards it. If they are being attracted or repelled, you can experience both of the things. For instance, the part of the material which you are placing with another part of another material, if they are the two opposite poles of the magnet, you will experience attraction or repulsion. But if nothing is happening, okay, because if you have a magnet, or how many of you have really observed the magnetic field by placing a magnet and doing something, placing something near to it or away from it? How many of you? Raise your hands. Okay.
Yes.
Very good. So you guys have an idea, okay? So you do have an idea. Let me check the other ones. Okay. So guys, do you have an idea how we're going to uh, experience that force? Okay, so this is these two methods are the methods we're going to use for magnetizing of an induced magnet or something that is an artificial man-made magnet. How can we demagnetize? So demagnetizing, there are three different ways. The first way to demagnetize is by hammering. So Omar, can you tell me what's going to happen when we hammer? I just told you guys about the arrangement, something happening. Yes. क्या कहते हैं? Particles or yeah, the atoms. Exactly. That's going to get disturbed, changed, disturbed. Yeah. Okay, the alignment or the arrangement is going to get disturbed, and we are going to have something which is not creating magnets. We can also do heating. Heating also distorts the arrangement. Okay, and another way is this is important, and that one is what you call the alternating current method. So a direct current magnetizes and alternating current demagnetizes. How? Because an alternating current is constantly changing the direction. Okay, so we are going to put this like this. But you know what's happening? We place the magnet inside. Okay, there's another question in which they can ask you about the steps. And you guys need to be very careful about the steps. This is alternating current. Okay, this symbol is for alternating current. Alternating current reverses the direction every half cycle. So we are going to place that magnetized object, not going to place, but you're going to move it. Okay, you're going to put inside, then remove it, then put inside, then remove it, then put inside, then remove. So what is this going to do? So this is going to again distort the arrangement of the molecules. Okay, are you getting or not? You are having a box in which we have some particles or some marbles, and we just shake the box. What's going to happen? Isn't the arrangement going to get disturbed? And it's going to okay, distortion will be there. So in the same way, the alignment of the particles which are there in the magnetized material, when it's put in inside the alternating current solenoid, and I'm going to remove it out, put it inside, then remove it out, over and over again. I do this, and the alignment is going to get disturbed. So in this way, we can demagnetize. So what they can ask you, number one, they can ask you that you are using direct current. You'll say no, direct current won't demagnetize. Number two, they'll say that we have just place inside and just put it, not moving. Again, this thing won't help you to demagnetize. So what are important things? Number one, there should be a solenoid. Number two, there should be alternating current. And number three, there should be pulling inward and then pushing outward. This thing should be happening over and over. Solenoid is basically an arrangement of coil which is connected to a supply. Okay. All right. Solenoid basically allows the current to flow into it. Is that clear?
Yes.
Okay. All right. So this was about magnetizing and demagnetizing. All then, all clear?
Yes, sir.
Yes.
Okay. Next thing is the magnetic field of a solenoid. Screenshots, please, and upload on the group. Okay. So, yeah, recording is there. Some of the students are like, okay, share the link with me, please. I'll share with all of them. Like, a few students are not there in the group now, so they don't get access to that. This is something really important. They can ask you to draw this. A very simple and mark any question. So you must P6 में तो नहीं आता P4 का है P4 में सोलिनॉइड वाला P6 में प्लानिंग के अंदर but you don't need to memorize anything anyways okay what is solenoid basically solenoid is an arrangement of coils wrapped around together okay this is a solenoid simple there is nothing hard and fast with the solenoid okay so now you guys need to remember that what is going to happen with the solenoid so there is a rule there's a rule the side from where the current is entering okay the side from where the current is going to enter, that side is going to be the south. And from where the current is leaving is going to be the north. Okay? So the rule is this is going to be the south and there's going to be the north. Okay? So side. Okay, beta, is that clear? So I can swap this as well. Like if I'm allowing the current to enter from here. So in that case, we have the things reversed down. So in that case, what we are going to have, and this is going to be the north. Yeah, that's going to be the south. Okay. So you guys very well know that the magnetic field lines they generate from where which side they generate? From the
North
north
to
to
south.
south. So you are going to draw the field lines which will originate from the north and they'll go towards the south. Is that clear? Okay. Yes. I'm telling you. It's going to be simple. So the first one, for example, if it is north, so you can draw some lines like this. Okay, there will be continuous field lines. Okay, like you draw a central one. Okay, and then you draw field lines like this. Okay, the main thing is your arrows. Okay, the main thing is your arrow. So for if this is north, okay, so you're going to north, okay, originating from north and going towards south. Getting? Okay, like this. So you guys can draw the other one as well. क्या हो गया मिडिल वाले में नॉर्थ से गया साउथ की तरफ आया साइड साउथ की तरफ एंटर होता है नॉर्थ से बाहर निकलते हैं Basically, this is the thing. This is your north. Okay, this is north. It's actually going like this. Getting? Yes. Okay. You can draw more lines. Even more lines you can draw if you want to draw more lines. Okay. So you're going to put the arrows away from north and towards south. Is this clear? You can do the same thing with the lower one. So this goes like this. Okay. So now the orientation changes out. You're having north on the left side. Okay. So three lines originate from the north going to the south, going from the north to the south. Okay. I want you guys to draw this in your notebook, please. Although the video recording is there, but you must know how to draw this. This is something really important. Done? Can you move on?
जी सर.
Okay.
Teacher, I did not understand the magnetic field difference. Can you explain it again?
The magnetic field lines, they always come out from the north side. Okay, like this. Just look at this. They're going away from the north and they enter towards south. So the middle line you're just going to draw straight, but the other lines you're going to draw spiral. Okay, the field lines. So in the same way, the rule is that whatever part of solenoid the current is entering, you will consider that to be south, and the other part will be north. So current enters from south, leaves north. Okay, so the south pole will have the lines going inside. Okay, and the north going outside. That's it. So the things are reversed for the loop. Is it clear?
Yes, I'm clear.
Okay. Now the next part is that this is done. Okay, part number one is done, and the next part is electromagnetism. Okay, and then we'll have electromagnetic induction. Okay, guys, what comes in your mind when we talk about electromagnetism? Those who have studied this with me or at school or anywhere else with an idea, they can share their ideas, please.
Sir, electricity and magnetism.
Very good. Electricity and magnetism, the merger or the correlation between them. Oh,
जी सर,
yes, yes,
AC
yes,
motor,
yes.
DC motor, ये सब.
Very good, very good. Very good. So electromagnets are those which only get magnetized when electricity is passing through them. Nice. And as soon as you switch off electricity, from that it again becomes a non-magnet. Wow, very good. All right. So electromagnetism, the first guy who observed this was Fleming Oersted. He was doing an experiment and he was having a wire from which the current was. Oh, I just forgot one thing. I forgot. Oh, my bad. Pardon me. Like, yeah, अगर ये आ जाए ना, how you guys are going to plot magnetic field lines using a compass. So what you guys are going to do, you're going to have a piece of paper. This can be an investigation, okay? You're going to have a piece of paper, okay? And then you're going to place a magnet, okay, like this. Your North Pole, the top, south, and the bottom. Okay. So the north of the compass. How many of you have seen a compass? The needle compass. All of you must have seen. Boys ने तो जरूर देखा होगा ना. So the compass is something like this.
Yeah.
There is a red one, okay, and it's used for navigation, okay. So no, so red one is always north, okay. This is south. So what is going to happen? Like I'm supposed to plot the magnetic field lines. What I'm going to do, I'm going to put the compass needle over here, and the north of the needle is going to be deflected by the north. They are going to be repelled, okay, like this. You're going to repeat the procedure, placing your compass all the way. हाँ
ये
बोलो.
शायद नहीं वो जिस साइड पे इसकी जा रही है पॉइंट उस टाइप में मैग्नेटिक फील्ड बना देंगे
Exactly. So what you're going to do, you're going to put a mark with a pencil, okay? And then you're going to just move it all the way around. As soon as you're going to reach over here, okay? There'll be so many points you will be doing, okay? You will be over here, you'll be over here. But as soon as you reach this point, so you see that the magnetic field is attractive in nature, and you'll see the field lines entering towards south. Okay, then you're going to remove your compass, you're going to remove your magnetic needle, and then you can have you have traces. Okay, so you can observe that there's done 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 done.
सर तो ये अच्छा ठीक है तो ये क्लॉकवाइज एंटी क्लॉकवाइज दोनों तरफ हो सकता
Mhm, exactly. You can just move it all the way around clockwise, and then the other way, and in this way you will have the field lines being drawn. Okay, so this can be a 3 or 4 marker investigation. It could be asked in your paper 6 as well. All right. So this is the thing. It's clear to all of you. Can someone quickly let Abdul Rahim know why he's left? So important class. I don't want anyone to leave this class. Okay. रिपल्जन होती है ना उसके उसके नीडल रिपेल होते होते फिर वो अपना वो इट विल स्टॉप वर्किंग after some time it will lose magnetism for some reason, okay, because there's going to be opposite fields, okay. So repulsive fields are opposite in nature, no, so they are opposite in nature, they are going to cancel out each other, so cancellation, okay. Please give me a second. So if you have any questions to ask me, if not, we are moving to. Okay, Zabardast. He's saying a region. Great. So electromagnetism is when you are having your electricity flowing and magnetism induced because of it. Now the thing is going to come. So they will ask you to draw the magnetic field lines, okay, because of a wire carrying current. So let's consider this is a wire carrying current, okay, and you have to draw the field lines, okay. For this, you're going to use magnetic field lines due to current carrying conductor. So you guys are going to use Fleming right hand rule, and then we are going to study about Fleming left hand rule as well in the second half of the class. So this is Fleming right hand rule. Okay, so my dear students, what you're going to do, for instance, the current is going from bottom to top like this, okay, and in the second one, the current is going from top to bottom. So you guys are going to do, okay, first thing you're going to do is to draw 3 concentric lines. The first one is going to be very near, okay, The second ring a bit far. They can ask you to draw 4 lines, 5 lines, how many, whatever the number of lines I've asked you, you're going to draw. So these are concentric lines. What do we mean by concentric? Concentric means that they are going to have the same center of the circle. Okay? But they're not having equal spaces between them. Please remember this. These lines are okay, I'm ready. No worries. So these lines are basically the first one is quite near. Okay. Okay. So this is a 4 marker or a 3 marker. Now the question is, why? It is so easy, baby. So my dear students, you need to remember 3 things for this. Why this is a 3 mark question? Number one, you have to draw the concentric field lines, okay, in such a way that the first one is closer, a bit far, and the farthest. Number one. Number two, you guys need to remember that if the current is less, so the field lines are going to be far separated. Okay, you have to remember this. Please note down this. Write down. The closer the field lines, the stronger is the magnetic field. एक दूसरे से करिए, एक दूसरे से करिए, एक दूसरे से करिए कि जितने करीब होंगे उतना स्ट्रॉन्गर फील होगा. अब they can ask you to draw on the same figure what's going to happen when you have less amount of current flowing in the conductor. So the same thing can be drawn, but you will have far away. Okay, the field lines will be far apart. So the first one near, more far and farther, like compared to the other one where you have more current. Okay. Now the most important thing is the direction. So for this, we are going to practice a Fleming right-hand rule. Okay. Now all of you must take your pens in your hand. Done. Now the tip of the pen with your right hand, because we're doing the right-hand rule. Okay. The tip of the pen must face, for the first diagram, it must face upward. Done. Upward. हो गया? Okay. अरे क्या कर रहे हैं? Have you done this?
सर समझ नहीं आया क्या मतलब.
समझ नहीं है. किसने कहा ये?
मैंने
अच्छा,
सर
देखो.
ये
कौन है? अब्दुल रहीम.
रहीम.
अच्छा, अब्दुल रहीम, चलो अब समझ आ गई. सर नजर आ रहे? ये नजर आ रहे? ठीक है. And you're going to have this facing upward, and you're going to flip your hand like this. करो सारे करो. Hold your pen, your thumb facing upward, and the tip of the pen going towards the sky. Do it. Done. Okay. Then you're going to curl your fingers. Curl your fingers. हो गया? अब देखो, when the current is flowing upward, your thumb is towards up. You have curled your fingers, and what's the direction of the field lines? Direction. Is it clockwise or anti-clockwise? देखो, ये पेन आपने पकड़ा. देखो, pen. Okay. Tip of the pen facing. The current is flowing in this direction. The current is flowing in this direction. Okay. Your thumb is facing in the direction of the current. Now you're going to curl your fingers like this. So can anyone tell me, are the fingers curling in the clockwise direction or anti-clockwise direction?
Anti-clockwise.
Anti-clockwise. Anti-clockwise. Anti is like this. Tuck, 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 tuck. Okay. So it's anti-clockwise. Done.
सर दोबारा
Okay.
explain कर दें.
दोबारा एक्सप्लेन कर दें. ये देखिए, ये आपका पेन हो गया. ठीक है. इसको आपने पकड़ा. अपने थंब को अपने डायरेक्शन ऑफ करंट में लेके जाना. ठीक है.
सर कुछ
और
बोल
फिर
नहीं रहे.
अपने फिंगर्स को कर्ल करना है. कैन यू सी मी नाउ? ठीक है. थंब
सर अभी भी नहीं.
कर्ल. Okay. So is it clockwise or anti-clockwise? ठीक है भाई. Again, actually, anti-clockwise. ठीक है. अब again current ऊपर से नीचे आ रहा है. That's coming from top to bottom. So you're going to hold your pen all the way like this. ठीक है. thumb downward, and then you're going to roll your fingers. In this case, what's going to happen?
Sir, clockwise.
Clockwise. बस हो गई बात खत्म ठीक है भाई
शुरू नहीं हो रही सर मेरे को अभी पुरानी स्लाइड है
क्या चीज
सर मेरे को स्लाइड चेंज ही नहीं हो रही मेरी कैमरा भी नहीं शो हो रहा
ओह नो अच्छा फिर मैं तुम्हें बताता हूँ ये क्या
नहीं सर
रिकॉर्डिंग हो
कैमरा
गई
तो
ना
ऑन था
रिकॉर्डिंग हो गई है ना ठीक है वीडियो देख लेना समझ आ जाएगा सो व्हाट वी आर गोइंग टू डू वी आर गोइंग टू ड्रॉ द फील्ड लाइंस ओके all the way like this and the first one is anti-clockwise isn't it okay anti-clockwise and for the other one is clockwise is that clear okay so this is for your current coming out of like upward and downward okay now my dear students you must remember that if we have the currents in the same direction if we have currents flowing in the same direction थोड़ा सा इसको देखना current flowing in the same direction up and up so now what's going to happen yes both are up and up okay so both are going to be we just discussed they are going to be anti-clockwise okay so that you need to remember anti-clockwise 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 देखो ये यहाँ से यूँ आया this is going to go like this going to go like this there's this okay that one is also anti-clockwise so anti-clockwise is this okay and it's going to be like this okay and this is going to be like this anti-clockwise anti-clockwise and then this one is also going to be anti-clockwise okay so can you guys see here that these two currents they're not in the same direction okay so their fields are going to be attracted okay so what we have observed that currents flowing in the same direction their fields are going to be attractive and if currents are going to be in opposite direction let's see what is going to happen if we have something like this
Sir, repel to
डिपेंड हो जाएगी ठीक है क्योंकि एक तुम्हारे पास जो है वो होगा लाइक one is going to be in the clockwise direction and the other one is going to be anti-clockwise is it clear
Yes, sir.
so we're going to have let's suppose this is going up and this is going down so for this one we are having anti-clockwise okay and this one is having clockwise same direction isn't it okay same direction okay so when there is same direction let's repulsion right so this was when the current is flowing up and down okay there is another case in which you can have something coming out of the page and into the page ठीक है अब ये जो है ना ये into and out of the page this is something which is challenging so what do you mean by current going into the page and current going out of the page तो उसको मैं बताता हूँ थोड़ा सा यहाँ देखो current going into the page का मतलब ये है कि the current is going towards the screen ये into the page है ठीक है into the page this one and out of the page is towards you okay this is बोलो मेरे साथ current going into the page and current going out of the page
Out of the page.
ठीक है अब वही we are going to use the same right hand rule you have gripped the pen with your right hand your thumb facing towards the screen and you're curling your fingers all the way like this ठीक है so into the page now look so this is into the page okay so when the current is going into the page so if you are going to draw the field lines so can anyone tell me what is going to be the direction of the field lines
say clockwise
Yes, sir, clockwise.
okay so just look at this so this was your into the page you grip with your right hand and then you curve your fingers all the way. Like, so it's going to be clockwise. Very good, my boys. Okay, so this is going to be clockwise. Okay, and the other one, when it's coming out of the page, so what's going to happen?
Anti-clockwise है.
So the symbol for out of the page is a cross. Okay, so the it's coming towards you. ठीक है भाई? Anti-clockwise. Is this clear? Same
Yes,
three
sir.
field lines to be drawn. The first one is closer, second one far, and the third one more far. Okay. And if you have a stronger current, they'll be closer, and if you have a smaller current, they're going to be far apart. Okay.
I
ठीक है भाई? Yes.
when I'm pointing the pen into the page,
Yes.
it's going anti-clockwise, and I'm
No,
pointing
no,
the
no, please,
pen
please, look at the screen. I'm showing you. It's like this. It's all the way like this. So your fingers should curl like this. Okay? Okay. चलो मैं जाता हूँ नमाज के लिए. आप लोग इसकी प्रैक्टिस करें. 10-15 मिनट्स के बाद इंशाल्लाह आपसे दोबारा मुलाकात होगी. ठीक है.